Hey, today's lesson is on chemical nomenclature, and remember, science rocks. So what is chemical nomenclature? Chemical nomenclature is the process of naming chemicals. Scientists from all over the world have made it very specific how we name them. So everyone is the same, so we can compare everything. Well, for naming chemicals, we need to have this handy dandy little piece of paper. Because the first ones we're going to do are going to involve binary compounds. So what's a binary compound? Let's look at that word. Binary compounds. This must be a compound or chemical with two elements in it. Compound with two elements. When we name compounds with two elements, they have the basic rules of all naming compounds, and that is the sum of the oxidation numbers must always equal 0. Must always equal 0. All right, so what do I mean by that? Well, for example, if I would take, let's say I'm going to take calcium. I'm going to want to make a compound with it so it works with chlorine. All right, so this is calcium. This is chlorine. Now, from our previous discussion, we know where oxidation numbers are by looking at the periodic table. So if we look at this, remember that the periodic table, the oxidation numbers kind of can be correlated to their column number. So these have an oxidation of -1, meaning that they're going to have, a positive one, meaning that they're going to lose electrons. Then over here on the right hand side of the periodic table, they're going to gain electrons, so they're going to have a negative charge. Now, I like to put the negative first because it always reminds me, hey, they need 1 electron, and these guys need 2 electrons, and these guys need 3 electrons. All right, so let's go back to my problem here and say, okay, what must happen here? I have calcium. I see calcium is in column 2. That means its oxidation number is a +2. So I'm going to write a little +2 here. And I go over to chlorine. Chlorine is on the right-hand side. And I look in the column, it has a -1 charge. So if I'm going to make a compound out of this, their oxidation numbers must always equal 0. When I look at this, I go 2 plus -1 does not equal 0. So the only thing I can do is add a thing called subscripts. So we'll put a new word over here, subscripts. Just to remember that word. I'm going to add subscripts to this and help me make a formula for it. So I look at +2. If I take this one times 2, if I can get 2 of these, notice then that 2 times -1 is -2, and I have a +2 and a -2 together, and I have 0. So my formula would be CaCl2, because I need 2 chlorines for every calcium. Now, how would I name that? I have the formula, but how would I name that? When we have a binary compound that is a metal, meaning an element from the left-hand side and an element from the right-hand side, in other words, a cation and an anion, we use the full name of the cation and then the root of this and the suffix "ide." That sounds like a mouthful, doesn't it? So I'm going to say it is metal, followed by the non-metal root. What does that mean? Then "ide." So here the metal is calcium. the nonmetal root, the root of the word, is chlor. And then I finish it with IDE, calcium chloride. Okay? Let's clear up that screen just a little bit there. Maybe that's a little bit better. Let's try another one. Let's find another element that we can put together. How about potassium and oxygen? I want to put those two together. I want to add those two and make a compound out of it. So let's do that. The first thing I do is I go to my periodic table and I find potassium. Potassium is right here. It's a K. It has an oxidation of a +1. I'm going to do it all at one time. So a K and a +1. I go find oxygen on my periodic table. Oxygen in column 16, it has an oxidation number of -2. So I write O for oxygen, -2. Kind of looks similar, just backwards, right, of the previous one. And this one, I see that this is a -2 and this is a 1. If I add them together, I do not get 0. So what I need to do is I need to figure out what can I take times something. I can't divide. I can't have halvesies, okay? No halvesies. I have to take something times something so that they're going to be additive inverses, or they're going to add up to equal 0. Well, this is a 2. Does 1 go into 2? And you'd say, yes, it does. Twice. So I'll put a 2 here. So now I have 2 plus, now that becomes a a positive 2. Sorry about that. A positive 2. If I take the positive 2 minus 2, I get 0. So my formula, I'm just going to rewrite it now without the oxidation numbers, is going to be K2O. Now let's look at the name of that. That name follows the same one we just did, metal, non-metal, rootide. So I look at this and I'm thinking, okay, this I know is potassium. I just looked it up before, that was in the question, right? Potassium. And this is oxygen, so oxide, potassium oxide. Let's try a few more with formulas already written for us, okay? Oh gosh, that one's going to be easy because we just did it. So let's go on to the next one. Well, we can write it down just in case. K2O, right? K2O. Didn't we just do that one? So I go on my periodic table. We're just naming them now. Just naming them. I'm going to go through there and I say, okay, K is potassium. O is oxygen, but the root of oxygen is ox. And then I added IDE. Let's do the next one. Let's find Mg on the periodic table. Have your periodic table handy. If I look on here, I see Mg is magnesium. So I'm going to look up magnesium. and write it down right there. It's my non-metal, and I have an I. I is iodine. It's going to be kind of a funny word, I think. It's going to be I-O, iodide. See again, root and IDE. Okay, the next one. You know what the name of Al is for the symbol Al? It's aluminum. Please continue to look up these words if you don't know them. We have a Cl. Again, Cl is chlorine. So what's the root word? Chloride. Let's try a hard one. They're not so hard, are they? Well, they can be. I'm not going to lie. Okay, I'll look at this one. Let's look at this. Do you know what sodium is? This is sodium. You know how to remember it? Remember the song. Na 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 na. Hey hey hey. Sodium. That's how I remember it. So this is sodium. I look up N. It's nitrogen. I write the root down. Nitride. Again, if you don't know what the root word is going to be, I would like you to give it your best shot, okay? Let's do the next one where it has a BA and a P, BAP. That's not what it really is it? So BA, probably here, number 56 on the periodic table, barium. And we're going to go find P on the nonmetal side. It's phosphorus. That's going to be a big word, isn't it? So scientists have kind of helped us out a little bit, and it's phosphide. It's not phosphoride, it's phosphide. All right. That wasn't so bad, was it? I hope not. I hope I explained it well enough that you can understand that. Now, if we go backwards and we have the name and we want to write the formula, there's a little bit more work involved. Because now I have to look up oxidation numbers. So let's look at that. I'm going to find, they want me to use sodium and bromide. Do you remember the trick of learning what sodium, the symbol for sodium is? The song, na na na. Okay, so that's the Na. Now I'm going to look up the oxidation number. The oxidation number for sodium is a +1. I go and look for bromine. Bromine is number 35, and it has the oxidation number of -1. Now, remember, all the oxidation numbers in a formula must equal 0. So I look, +1 minus 1, that equals 0. So without writing the oxidation numbers, this is the formula for sodium bromide. Let's look at calcium chloride. Calcium. Let's find calcium. Calcium is in column number 2. It has an oxidation of +2. Write that down. Chlorine is in column number 17. It has an oxidation number of -1. Now look, these two added up together do not equal 0. So what do I have to do? Remember, no halvesies. We can't half this. Can't put a half on here. We're going to use subscripts. So I have to think, okay, this is the smaller one. Can I take something times this number to make it opposite that number? So if I take it times 2, 2 times -1 is -2. 2 plus -2 is 0. That's what I'm going to do to create a formula, or write a formula that follows the rules and has all the electrons accounted for. Let's try one more. Oh, maybe a couple more. Magnesium is the next one. I found magnesium. It's in column number 2. It has an oxidation of a +2. Now I go to the other side and I find sulfur, because that's what sulfide is sulfur. I find over here it's in column number 16 and it has an oxidation of -2. So sulfur is -2. Do the oxidation numbers added together equal 0? Yeah, they do. So our formula is MgS. Let's try one more. I look again at, I see aluminum. Do you remember the symbol for aluminum? I do. It's right here. Now I'm going to tell you a secret. See this little number right here? I don't know if you can see that, but that says it's a +3. That's the oxidation number. Remember when I had you look at the column before magnesium? Look at magnesium has right above it. It tells you this periodic table is amazing. It tells you so much information. So I'm going to look over here in aluminum. It has a +3 oxidation. So I'm going to write down that aluminum has a +3 oxidation. And then I look at oxygen, find oxygen. See what it says right there? -2. What does that say right there? -2. I know. Like magic. Oh, -2. Oh my goodness. This looks like it could create some problems, because when I add those together, it definitely does not equal 0. So what do I have to do? Well, 2 doesn't go into 3, and 3 doesn't go into 2, but they both go into what number? 6. So I think to myself, self, what do I take times 3 to get 6? And I would say, self says 2. And how about oxygen? What does it take to times 2 to get 6? And self says 3. Let's see if that works. I have 2 aluminum plus, with each plus 3, which give us a plus 6 over here. I have 3 -2's, which gives us a -6. If I add these two numbers together, what do I get? 0. Perfect. So now I have aluminum without, I'm going to write it now without the oxidation numbers. And there's my formula for aluminum oxide. We will cover more later later on, so you have a better understanding of this. But I hope this gives you a working idea of how to name binary ionic compounds.